Welcome to the Math Record. Today I'll be covering the ICTM Regional 2015 Division AA Freshman Sophomore 8-person, which I'll be answering questions 10, 17, and 19. And as usual, scroll down all 20 questions, and I'll give the answers at the end. Okay, let's begin with number 10. For some real value of b, the graphs of y equals x squared and y equals negative x minus 6 squared plus b intersect at exactly one point. Determine the coordinates of that point. So let's just set them equal to each other. So x squared is equal to negative x minus 6 squared plus b. So that's x squared is equal to negative x squared. So that's minus 12, so that's a plus 12x, and then minus 36 plus b. Move them all to one side, so that's 2x squared minus 12x plus 36 minus b equals 0. So basically, the key words in here is that it intersects at exactly one point. So we use the quadratic formula is negative b plus or minus b squared minus 4ac over 2a. So for it to only intersect at one point, that means this value has to equal 0. Because if it's anything other than 0, then basically this value will have two possible, because you're going to add a number and subtract a number. So there's two possible answers. So that means this has to be 0 to intersect at exactly only one value. So that means it has to be just negative b over 2a. So what's our b? Well, our is negative 12. So negative of negative 12 is 12. And then 2a, a is 2, so 2 over 2 is 4, so that means equal to 3. So this is x, so x is equal to 3. Now to find our value, just plug into one of our equations. So let's just use the easiest, which is y equals x squared. So that means our y is equal to 3 squared, which is 9. So that means our coordinate is 3, comma 9. And that is our answer for number 10. So we don't even have to look for b. We just need to recognize that it's just in that form. Okay, question 17. A cubic polynomial has three distinct zeros, r, s, and w, whose sum is 0, whose product is negative 15 over 256, and the sum of whose squares is 19 over 32. Determine the sum of the reciprocal of the zeros, 1 over r plus 1 over x plus 1 over w. So we know that the sum is 0, so r plus s plus w is equal to 0. And we also know that the product is rsw, which equals to negative 15 over 256. And we also know the sum of the squares, so r squared plus s squared plus w squared is equal to 19 over 32. So we need to find this, which is just equal to s over sw plus rw plus a rs over rsw, because that's just simplifying with the same denominator. So basically this, all we have to do to get this value is that instead of squaring them, adding the sum of the squares, all we have to do is just add them together, and then we square it. Because this will give us r squared plus s squared plus w squared, and then plus 2rs plus 2rw plus 2sw, which is this, but just 2 times as much. So we have to take away this value, we have to take away r squared plus s squared plus w squared, and then divide by 2 to get this. And then we just need to divide by our rsw to get our answer. So this is the same thing as this. So what is r plus s plus w? Well, that's 0, so 0 squared is just 0, minus, which is just a negative, and then r squared plus s squared plus w squared, which is 19 over 32. So 19 over 32 divided by 2 times RSW. So RSW is negative 15 over 256. So that's just negative 19 over 32 times 256 over negative 15, right? Dividing by a fraction is the same thing as multiplying by a reciprocal. And we're still multiplying by a half because it's on the bottom still. So 32 and 256, this is pretty common. That is just equal to 8. So, and then this 8 cancel with this 2 to make a 4. And then this negative cancel with this negative, so we have 19 times 4, which is equal to 76, and then we have a 15 on the bottom, which we can't simplify. So we have 76 over 15, which is equal to number 17, which is your answer for number 17. Okay, question 19. Determine the number of integers n where it's between 18 and 40 that has the property that the product of the distinct positive integral divisors of n is n squared. So if you kind of think about it, the only way for this to be possible is that it only has one other pair that can multiply to itself. So what I mean is, like, let's take for example 10. 10 is going to be 1 times 10 and 2 times 5. So if we ignore 1 times 10 because it's basically just that number, so that number and 1 would just be one of the pairs. So it has to be, so it only has one other pair, so 2 times 5, which makes its number. So then when we multiply all these together, this is a 10, this is a 10, so that's 10 squared, right? Which is 100. So that's a way to think about it. So all we have to do is look for a number that has another pair that only works with it. So that's only possible when you recognize that this is a prime and this is a prime. So it's only two possible primes. Because is this anything else? Let's say like 4 and let's say 3. It'd be 4 times 3 and then 2 times 6, right? Because you could just take away the 2 from here and then put it to the 3. So then has two other pair. So then has two other pairs. So it must be two primes multiplied to each other. So for it to be two primes, that means let's just list all the primes, which is 2, 3, 5, 7, and not 9, 11, 13, 15 doesn't work, 17, and 19. And then we can stop here because 2 times 19 is 38, which is the lowest for 40. So then let's think about which one works, because it has to be between 18 and 40. So 2 and 14, that makes 2 and 7 makes 14, doesn't work. 2 and 11, that works, that makes 22, which is higher than 11. So that's 2 and 13, 2 and 17, and 2 and 19. And then now let's try 3. 3 and 5 makes 15, that doesn't work. 3 and 7 makes 21, that works. 3 times 11 equals 33, that works. 3 times 13, which is 39, which works for 40. So we stop there because 3 times 17 is going to be 51, which is higher than 40. And then we have 5. So it could be 5 times 7, which is 35. 5 times 11, which is 55, which is higher than 40. So then we stop there because basically we because any other combinations higher than 5, 7 is just going to be higher than 40. So these are all our combinations that work for one is a 2 pair. But that's only if it's a prime times a prime. What's the exception to this rule? Well, let's think about it like this. So if we have, let's say, instead of something that is made by a bunch of primes multiplied to each other, maybe it's just one number multiplied by each other respectively. So how it will work would be like, let's say 2 cubed, which is just 2 times 2 times 2. So 2 cubed is equal to 8, and that's equal to 1 times 8, or 2 times 4, right? So it has two possible pairs because 1, 8, and 2, 4. So that's just 8 squared, which makes sense. So 8 works, but it's lower than 18 and 40. But this doesn't satisfy the pair because this is a prime, but this is a composite. So there must be one that works if it's just raised to a power of 3. So it's just one number multiplied by itself instead of having primes. So 2 cubed doesn't work because that's 8, but 3 cubed, that's 27. That's between 18 and 40. And then we have 4 cubed, which is 64, which is higher than 40, so that doesn't work. So the only combinations that work are these, which is 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we have 9 combinations that work for number 19. And that's basically how you do it instead of going through every single numbers between 18 and 40. And as promised, here are all the answers. Thanks for watching, and I'll see you at the next math record.